All right, guys, so we can get started again. What is it I was talking about? We're gonna introduce you guys. There's a lot of things, components in the back end, right? I don't know how much experience you guys have had related to programming or anything related to web development. So if you guys have any questions, raise your hand and ask me. Otherwise, I'm gonna move through the slide. Okay, so feel free to ask questions. Your points here is again making sure you guys understand the material. All right, so let's just get started real quick into the first slide. This is a quick overall capture of the flow between the front end and back end. Maybe throughout the last few lectures, you guys learn about doing the HTML, etc. on the front end to display a certain thing, the context, the content, the visual on the browser. So what you guys have been working with, I would assume, is just HTML related or JavaScript related on the front end. But the real world out there for any application, even the Facebook app on your phone, right? Your bank account, when you go log on to your Chase, your Wells Fargo, your Bank of America, is actually having two components. One is what you are seeing on the browser, that's the front end code, and also all the logic, all the magic happening in the back end. And the flow between the front end and the back end is between two different software. Put it simply, the software on the client is the browser. The software on the server side gonna be the application. That application, we consider them as a server code, server side code on the server. That could be JavaScript, Node.js, that could be PHP, that could be Java, that could be anything that you guys want to use. And that server component gonna do is all logic, or gonna do is all magic, like doing or handling anything with the database, interact with the database, creating, saving, etc., and producing an HTML ready piece of code, and then would return that from the server side back to the browser. So your browser would receive an HTML document that you guys are familiar with, and the job of the browser would be just render that document. So I have it in the presentation note very briefly, just kind of the overall understanding of different programming languages that we talk about. So that's two different categories. The HTML that you guys been learning, we consider them as a markup or meta language. And that language is not really have any logic in it. JavaScript is a real programming language, but HTML is just a markup, a meta language to describe the content. Okay, so the key point is meta, describe what the content looks like. Okay, you have a certain tag telling, hey, this content is a title, this content is a body, etc. Right? This content is a checkbox. But the logic of the interaction needs to be done through a real programming language. And maybe you guys have learned about JavaScript, allowing you to do some certain validation, etc. So that's the real logic. And also on the server side, we might have PHP doing running. We have Java, we have C++, whatever on the server side. Those are real. For another example, C++, real programming language that would instruct. So the keyword in here, instead of describing, it's instructing the computer to do a certain thing, right? So that's the two different understanding of kind of the front end and the back end side. And we put the overlay onto the same slide, just differentiate between what it means by the front end and the back end. Okay, so any question on the overall understanding of the components or whatever going on with the typical application you guys been using? So any question on that? So let me ask you, the Facebook application on your phone, it's not a web browser, right? It's an application. Do we consider that back end or front end? Well, yes, sir.
Front end, because all of your actual information is stored on Facebook servers, and the application is just communicating with that.
Someone has a different answer? Okay, so instead of Facebook, let me ask you, you guys use Google Spreadsheet? You guys use Google Doc? What is Google Doc? Is that a front end or back end? Google Docs, you guys modifying your data, right? Your information, or even Google Spreadsheet, you guys storing information in that spreadsheet, right? I don't know, your bills, the money your friends owe you, right? Or whatever. Is that front end or back end? It doesn't hurt to answer. Who said something? Raise your hand. Why is that? Okay, it's very good. Actually, she said something very good. User interface. So what is the real definition of front end? What is the real definition of back end? It's kind of loose, okay? But based on our understanding, front end is something that directly interfacing with the user. We call it front, right? It's like up front, on your face, in your face. Back end is something behind the scene that you're not aware of. So anything that have that user interfacing layer, we can consider them front end. So all the code that generate the UI that you look at, that you can interact with, we consider them kind of front end. Right? So the HTML is front end. The application on Android or iOS are considered front end because that's creating the user interface you are interacting with. The code that generating them is just the under beneath the scene code, but those code are not considered front end. For example, you've been learning about JavaScript, so we consider JavaScript as a technology for the front end. However, we can also use JavaScript as a programming language in the back-end side if we're using like Node.js framework, etc. Okay, so for today, we're going to talk about if we have the back-end code and we have the logic. I think in this class, maybe you guys touch it on PHP? No? Yes, Nyan? No? Okay, all right, so maybe in the next class where you would be learning whatever programming language that allow you to code up the logic in the back end, you could get interfacing that logic with the database for you to store permanent data. So in this class, we're going to learn about databases and what it means. So for a database, it's just a collection of data. Okay, so a space for you to store information, simple as that. There are 3 goals for the database with the data that you want to store. So basically, you want to store them. Another way of thinking or talking about it is inserting data into your database. Another thing is to manage them. With manage meaning that we're going to play around with them, we're going to edit them, we're going to manipulate them, right? And the third one is that, hey, you store data, you manipulate them, but again, you want to look them up, you want to retrieve them. Okay, so that's kind of the third goal for having a database. Database is basically just your storage information. You want to store, you want to manage, and you want to retrieve them. With the database, there will be an interface that allows users to interact with the database. There could be some GUI, graphical user interface, that allow you to have a nice looking visual screen interacting directly with the database. There might be some other layer of the interface through the programming code. The layer that we're going to be introducing you guys with, maybe in next class, this is just a sample of what it looks like, would be the SQL language. SQL stands for SQL, the short for SQL stands for, people usually call them select query language, but I believe that a more better term for that would be, I think, structured query language, right? So people kind of use those terms interchangeably, it doesn't matter. Either structured query language, it's a language that allows you to query the structured data, right? Data that are structured in columns and rows, that's what it means. The most typical syntax in SQL is a select statement. It's called select. And that's why people keep referring to SQL as a select query language, right? It means the same thing. And this is an example. Really, we have a select example in there for you. This one, what the meaning of it is select store, meaning that you want to select everything from the table called users. And then you want to list the result by ordering the name of the user. So that's what that little syntax means. In contrasting with the interface of allowing you to interact with the database through the SQL query, the SQL language, we have the NoSQL version of that. So with the NoSQL, you have the user collection. You are applying the find function in that collection. And then the next sentence, the next statement, is basically you're trying to delete from the user table a person with the name Tommy. You guys don't have to memorize any of this. This one is just giving you a quick taste of what the real syntax for SQL or NoSQL interface between you as a developer and the database would look like. Any question on this? All right. Have Nyan show you guys, probably maybe this class, but have she ever talked about the PHP admin? No? All right. Nothing backend. Anything with database? Not at all. Okay. Let me try to think. Have anyone ever used? You guys use Google Docs nowadays? You guys use Google Sheets nowadays? Anyone still using Microsoft Docs? Microsoft Document? I'm sorry. What is it?
Word.
Word. I used to work for Microsoft 14 years ago, but I don't know why. So Microsoft Suite, their Office Suite, yes, the Word, and then Excel. Anyone ever heard of Access?
Yeah.
What is it?
I mainly use it the same way you would use SQL, to be honest.
Okay, so what does it do?
It's more of a database, to be honest.
Okay.
Forms your backend.
Okay. All right. So Microsoft Access is a user-friendly, Office-friendly version of a simple and small database that Microsoft created. The reason I'm asking is just kind of see if you guys have ever experienced with that. Nowadays, people kind of moving all of our tools through online, so that Microsoft Access is kind of outdated and not many people use or know about. The reason I'm asking is because I want to mention that. I want to point out that for us as a programmer, we interact with the database through an interface. Our interface would be programming related tools like this, SQL or NoSQL programming languages, right? But for a regular user, they could interact with the real database through some sort of GUI. So that GUI could be the nice looking Microsoft version of the Microsoft Access, or could be the MySQL Workbench software that you guys are going to be learning about at the end of this class or early next class when I'm going to introduce you guys to that. So that is also a tool that kind of user friendly if they don't know much about the database. However, it can also be used by the programmer as well. So that's another example of an interface. So to be able to interact with the database, we have a variety of tools. Okay. So people might ask, the previous slide has the example of what the syntax would look like for the programming language, or the minor syntax we would use to interact between SQL and NoSQL. But in terms of capturing the data, how the data would look differently for the SQL world versus the NoSQL world. Quick quiz question. Anyone knows what NoSQL stands for? Well, what is can we make an educated guess? Well, we don't know everything. And this is one of the tips I usually tell my students, is that when you go to an interview, don't play dumb, play smart. If you don't even know the answer, and more than half the answer you won't know about, seriously, you gotta be able to say it out loud and make an educated guess. What they care about is your ability to analyze. They don't care about whether you get the answer right or wrong, right? So you guys are all educated. We build our knowledge based on whatever we learned before. So with this, did we learn about SQL in the last 5 minutes? Right? And now we see the phrase that say no SQL. What would be our educated guess? I saw a hand somewhere.
No select query language.
All right, stop Googling my answer. All right, if we were to make an educated guess, we would say, all right, this is a language that has nothing to do with SQL, right? Because the word no literally is spelled right there. If we have a term that says yes SQL, what is the educated guess?
That it's SQL.
Yeah, I made that up, but that would be the best educated guess answer, right? Thank you for Googling the NoSQL. He's very smart, but in the interview, they might not give you a computer to Google it. The correct term, if you were to look it up out there, actually is say for not only SQL, meaning that SQL is not the only tool that allows us to interact with the database. There will be other set of tools that we put in the bucket of not only SQL, right? And they kind of shorten it to NoSQL. It's mainly the same thing, not only a no, meaning that's the opposite of SQL. All right. So if we are talking about SQL, this could be the data, the real content in the database, if we were to lay it out in the SQL world. This is very familiar with any table, Excel, or spreadsheet that you guys have ever seen, right? It's just a collection of rows and columns. Do I have a slide next to talk about that? Yes. So each of the rows, there are a couple of terms having or meaning the same thing. and you guys need to be familiar with that once you guys start reading all the article or materials online, okay, to catch up with your knowledge, to learn more. You can consider that as a row or record or instance. They are all means the same. Okay. And for the going forward, for the columns, we consider them a column, a field, or an attribute. Okay, and some people refer to that also as a characteristic. They all means the same thing. So for example, in this table, can someone tell me what are we trying to capture? What are we trying to store? Quick answer, quick answer. It's 10 a.m. It's not like 8 a.m. I woke up at like literally at 6:30 to try to get here. And I pay for the parking here. So you guys gotta do me some favor. What is it? What are we trying to capture in here?
Besides data.
What's that?
Besides data.
No, data. For data, what are we trying to capture? Literally on the slide. Okay, the content that representing the list of user, right? So for each record, we are trying to capture the content information of a user. Okay. So the reason I'm asking you guys, not making fun of you guys or trying to make you guys stay awake. The reason I'm asking this to you guys again, you guys, I don't know how Nyan been prompting you guys questions, but you guys need to get into the habit of being very active, of picking out the answer and saying it out loud. I would say it's like one of the best skills you would have if you don't have any internship or a job yet. At an interview, don't stare at the question. Even if you don't understand the answer, if you don't even understand the question, speak out loud on what the heck you don't understand about the question, so that the interviewer would rephrase the question to you. If you're being silent and because you guys right now are practicing the inactive mode, and it's kind of becoming your habit, you guys got to be more active into, all right, I know this, let me think about it, let me answer it out loud. All right, so besides storing the record there, what all the main information are we trying to capture in here? Can we spell them out? For a user, what are we trying to capture?
Their name, their ID, email.
Perfect. All right, so we can capture the main information representing them. Okay. Even though all the information is here, but the way you phrasing or rephrasing your understanding is very good. It helps you to have a different perspective on the same information. It's also tell the listener that you understand what is being captured in here. All right, so another example could be this table. This comment would be literally the Facebook backend of all the comments we see on Facebook, right? Someone posts a picture, I do something, this sucks. What is the other one? All right, best video ever. That one would be on YouTube. Someone watching a video. The next slide would be, if we were to have those comments listed, we know who make those comments, whether they are from Facebook or YouTube. So how do we capture the relationship between the people who make those comments? So this would be a very simple example illustrating to you guys. If you guys need to design a database or the table, keep it simple, the table to keep track of the information, you would need to have two tables. One table literally listing out all of the comments that ever made. On another table, you would be listing out the people or the person who had made that comment. So in this table right here, let me ask you, how many comments have user 1 ever made? How do we know that?
There are 2 comments associated with user 1.
Okay, very good. What is the comment content, the text comment that user 4 made? What was his comment? Okay, when are you uploading the next video? Right, so by doing this very simple exercise, very obvious, but you can kind of see how we store content and how we kind of associate content between one versus another. Okay, one entity versus another entity. And the question I ask you guys, how many comments have user 1 made? That is actually a query that you guys might face in the near future. Someone's gonna ask you that question, or you need to program your code to answer that question. So remember literally how you said out 2. So I want you to go back and think, all right, how did you come up with that answer, right? So you said 2. How did you come up with that answer?
I first looked at the relationship table and looked at how many times the user ID showed up in the user ID column.
Okay, what user ID did I give you?
1.
1. All right, so what did you do?
Look for 1 and how many times that shows up.
Very good. So literally that's the process that he have thought of, and that would be the same thing you guys need to think about, note about when you solve your query next time. So in here, this is a very simple example, right? But we're going to carry on top of that. The same way where I ask you, hey, what is the comment user 4 have made? Then you need to kind of trace back in your thought process, how did you arrive at the answer? Okay, in the presentation note, I kind of also want to point out, in this relationship table that we name it with the name user / comments, and so this is the name of the table. In this table, we try to keep track of the relationship. This relationship, another note we can make or can observe or can extract out is that a user looks like they can make many comments. A user can make multiple comments. User 1 have 2 comments. But a comment belongs to 1 and only 1 user. So that's another note that I want you guys to kind of be aware of based on the structured data we have in here. Could a comment ever belong to 2 users? Could you and your friends make the same comment? You and your friend could make 2 comments, but those are separate, right? A comment could belong to at most 1 user. So that's one of the important notes we're going to see later on at the end of the lecture when we talk about the relationship type. So in here, by observing the data, you kind of know those things. All right. So in the NoSQL world, the way we keep track of data is not in the table form anymore. It's not in the usual Excel sheet that we are familiar with. We are keeping track of them kind of in the text version of the information. We literally writing the information like this, using the text and a few special characters to kind of separate out the columns or the fields or the attribute versus their own true value, right? So in here, we kind of see the curly braces. We don't know what the curly braces for, right? We're going to learn about them later on, or if you guys look out there, it's basically just a way to separate out layers of data, right? And we're going to see the first name, what the heck is that, colon, mommy, etc. So if I have no idea what this one is, I haven't seen this syntax or this type of information before. What is an educated guess we can make about the content we're trying to capture in here? What are we trying to capture in here, guys? Someone else. You answer too much.
There's no problem with that.
Very good. But I want someone else. No, I'm just making fun of you. Someone else besides him. I give you 10 points.
Okay, thank you.
Already. The points don't matter. What are we trying to capture in here? Well, I haven't looked at this. What are we trying to capture in here? Some hands, guys. Yes, ma'am. Okay, and for that 1 user, what else are we trying to capture or we store for that user? Okay, the online comments, right? So basically, USC president hired some development firm to kind of keep track of the things you guys said online to see you guys say any bad things, right? And the people who said bad things are going to be put into this blacklist, and this is basically the database for that blacklist. All right, cool. You can do further readings. This last few slides basically just give you a taste of how we represent, how we store the data, and how the actual raw data would look like beneath or inside the database. Okay. Moving a little bit deeper into the SQL world, we're gonna look and talk more about tiny little things within the database for SQL. So this screen we already saw the same structure. In this screen, we're trying to, instead of naming them users, which is very generic, by looking at the data, we kind of see, hey, in this table, we're trying to keep track of the student information as USC, and there's a row and there's a column for that. looking at that table, we're going to be learning about one new concept today. If you guys have heard about it, that's great. If not, make sure you guys raise your hand and ask me a question. This concept is one of the most important concepts regarding databases. So there's a notion, an idea of a key. A key is a field. What is another synonym for field? Quick test. Someone say something? Column. What else? Attribute. Very good. One more that I said that wasn't on the slide. I have $10 for that person. It's not 10 points, $10. You guys want $10? Okay. $10 right here. Okay. It was characteristic. Right? Remember that? Right? A field has the same meaning as a column or attribute or characteristic. So all of those are kind of similar terms that we should all be aware of, right? So this $10 belongs to me. I answered that. So a key is a set of, could be one single column or could consist of multiple columns. Okay, and that single column or that set of columns, once you know the value of that, you could literally know the whole record. So that's the definition of a key. So knowing a key, you would then uniquely identify the whole record. So that's the definition of a key. In this simple table, without looking at and cheating, just look at the screen. Can you tell me which column in here that if I give you a value, you can identify the whole record? So I'm gonna, yes sir. The ID. So if I know, I give you 2, you know who that is? If I give you 2, do you know the date of birth of that 2, the person? Right? All right, very good. What else? Is there any other possibility? Yes, sir. Say again?
The USC ID.
USC ID. Did you say that? All right. So if I know the user 74, ending 74, do we know the name of that person?
Yes.
Who is that?
Jane Doe.
All right, very good. Anything else? So ID by itself could be a key, right? USC ID by itself could be a key. Yes, sir. Email. All right. So if I know it's J.S. Smith at USC AU, do you know who that is? Do you know the ID of that person?
Yes.
What is that?
2.
2. All right. So by examining the data, you know that you have multiple options that can be chosen as a key. Actually, they are all keys. Knowing a value for that key, you can identify the whole record. However, all of those potential, or another term we call them candidate keys, you need to pick and choose one and only one as your primary key. Okay, we call it primary because that's the only thing we need to choose. That's the one we have to choose. So when you guys are designing your table, when you have the structure for your table, it would have multiple columns, etc. You're gonna examine all the data in your columns and then figure out, hey, you know what are the potential keys I could have? And out of those potential keys, you gotta pick and choose one and only one as your primary key. So the definition of primary key is that this is the key that is chosen in your table. So we talk about the ID, USC ID, and then the email. Okay, so all of those individually could be served. They are all keys, but each of those individually could be chosen as the primary key. Actually, let me go back one slide. Anyone have any questions, or are we super clear on the definition of the primary key? All right, so let me ask you this question. If you go to the DMV, anyone been to the DMV? What is the DMV?
Department
Not you.
There's no problem with me volunteering.
Someone else. All right, thank you for that. When you go to the DMV, how do the DMV identify me versus him? driver license, not driver license, specifically driver license number, right? Because the number are unique, right? I have a different number, he has a different number, okay? So when you guys, before you get to USC, when you at USC, how does the USC school identify you guys? Your USC ID, right? So we got that. Now my question is, when you guys were applying, you guys aren't the USC student yet. When you guys were applying to USC, how did they differentiate you guys? Say it again.
Common applicant.
Okay, he's saying basically the application account, right? If you go, probably not here, but let's say a big example in the United States. How does the United States differentiate us? All right, raise your hand if you don't have social security number. Okay, so that's a very good question, and the point I want to make is that yes, when you guys design database, obviously the primary key or the key is something that you must make sure that you test that the value of those is going to be unique for different people, right? Different objects, different records. But there will be a case that those values might not make sense for a certain record. So let's say in the United States, not everyone having a social security number. If I have a child, that child might not have a social security number yet, right? If we are a foreigner, we don't have a social security number yet. So you guys have to actually do that test and validate back to whoever working with you, whoever is a stakeholder that you guys are working for, and kind of balance out the question and answer. See, can we use a social security number as a primary key in that case? Because one of the requirement for a primary key, I don't have it in here, is that the primary key value cannot be known. Or another way of saying it, the value of the primary key cannot be empty. So we've chosen the social security number as the primary key to identify different people. Then for some people, we have the value for that. Other people, we would have an empty value. So let's say two people having the same empty value because they don't have social security number. How do we differentiate them, right? So that's the challenge. So in that case, we cannot use a social security number as the primary key. Does that make sense? All right. Can someone? Oh, never mind. Let me move on to the foreign key definition. So we know about a primary key. So what is a foreign key? Foreign key is kind of similar, but it's different. Foreign key is a new column in our table that we keep track of value of. But the value is actually coming on from a different table, from the primary key of a different table. The example of that would be in this course. So let's just focus on the course table. And if you guys notice, I throw in a synonym, a similar term for the word table. What do we refer to a table as? What else do we refer to a table as? Entity, right? Okay, so just throwing in new terminology, so we're going to use that later on. In the course table, what is the primary key for the course table? Yes, ma'am. ID. All right, very good. So that's what we chosen. What is the primary key for the room table? For the room table on the left-hand side. ID. Very good. Thank you. Primary key. And then we notice that in the course table, we have a column that's kind of telling us which room the course is in. And the value in that column are the value coming from the room table primary key, right? So in this instance, we consider the room underscore ID as a foreign key of the course table. The ID on the right-hand side is the primary key of the course table. The foreign key room ID is the foreign key of the course table, right? But this foreign key is actually linking or pointing or referencing, right? There's a few ways to say about that. referencing or linking to the rooms table's primary key. Does that make sense? I think I have it in the presentation note. That's like 3 different ways you guys can interpret this. Basically, it means the same thing. The foreign key references the value of the primary key in another table, right? Another way, the second way, the foreign key links the course table with the room table, right? The third way for us to interpret or say it would be the foreign key establishes the relationship between the course table and the room table. So by looking at the data, we kind of know the value of room IDs is picking out from the the foreign key, the column room ID is picking out from the room's ID column. But then we need to understand that hey, that value in the foreign key established the link, established the relationship. So we start hearing about the word relationship now, which we're going to be using later on in this lecture to define further things. So before I move on, anyone have any question related to the primary key concept and definition, or the foreign key concept and definition? Let me ask you this: in the room table, can we use a room name as a primary key? What is the definition of the primary key? Yes, ma'am. No, I'm talking about the room table. Oh. Yeah, so on the left table. On the left table, we know for sure that the ID, this one, is primary key, right? My question is, can the room name, I might have spoken it different, I was asking about room name, can the room name be a key or the primary key of this table? Yes, ma'am. We're just talking about this room table. I know where you are going with that, but let's kind of off track a little bit. I will revisit that, but let's just focus on this room table by itself, right? So on this room table, okay, a different question. What are we trying to keep track in this room table? All the different rooms, or information for those rooms, right? The same thing in this one, the main purpose of us keeping track would be the course information, right? The information related to the courses. Same thing for the rooms. The rooms might have the building, security code, columns, for those buildings, etc. In this case, we make the room tables very simple, only 2 columns. Repeating my question, can we choose the room name as the primary key for this room table, wherever on the right hand side, on the left hand side? Can we or can't we? Yes, sir.
Yeah, you can.
All right. So one of the key requirements for the primary key would be all the values have to be unique, right? Because that's the job of the primary key to uniquely identify the records. So yes, by examining this data, you could potentially choose the room name as a primary key. So I just want to point that out to you guys. When we are designing database, we have options.
But theoretically, if that the room table can just have one row, it doesn't need to have
So not record, but column.
column, right?
Right? So if we were to omit this ID column, yes, the room name in this room table that consists of only one single column content could use the room name as a primary key. Okay, so you guys might see some example of that in small piece of application or development to keep things simple. You can just, as long as you know everything is unique here, you can keep that as a primary key. In more convoluted or complex example, we typically creating a separate ID just to keep our management of the database easier, because again, things gonna keep growing. You're gonna be adding more columns, etc., and then you're gonna come back to the question you have. Will the room name still be valid, right? So it's easier for me to have a separate ID that we know that it's always going to be unique, because the way by looking at the data through all these examples, you kind of know that we're just keeping track of numbers, and if we increment them whenever we have a new record, right? So for sure they're going to be unique. All right, any question on that? Yes, ma'am. Okay, so very good. Yes. Do I have it in my next line? Maybe my next line. Yes, I do. Okay. So yes, the answer is in this room table we have 3 different records. Each of the or 3 different rooms. Each of these rooms has an ID, just like room number, right? So this is room number 1, room number 2, room number 3. In this course table, the main information you are keeping track of will be the information for the course only. However, you kind of want to know which room that course is in. So you put in the value of the room ID here, which is referencing to which rooms you want that course to be in. So the answer to your question, if I heard correctly, is that the room ID here is actually pointing to or linking to or referencing to the value of this room ID column right here. Did I answer your question? Okay. All right, so we talk about this example where the room ID on the left, what is it? On the left hand side referencing to the room ID on the right hand side. One thing we need to make sure is that the data type or the value has to be consistent, right? So if we want to reference the room ID in here, the value in here should be all of the possible value in here, right? It cannot be like A, B, C in here, because A, B, C in here is a different data type than this one. If we are trying to keep track of integer in here, this referencing table or this foreign key needs to be an integer as well. So INT, we kind of throw it in. So if you guys haven't seen that, that is just a way for us to specify different data type. So int is short for integer, meaning numbers. Varchar is short for, not short for, meaning variable character. Okay, meaning string. You have variable length of character. Yes, sir.
When you try defining a varchar 10 that's longer than 10 characters, does it not let you, or does it just cut it off?
Very good question. So he's saying that he's picking out that for the column course number and course name, if we know the type, right, varchar, and we see like the parentheses and a number thrown in there, like 10, right? So educated guess would be, hey, looks like we're keeping track of a string that maximum 10 characters, right? Something like that. And if we want to store this, interactive web development, how many characters is this? Very good question, right? Is that counting? It's kind of numbers to count that. But it's a lot. So obviously it's more than 10 characters. So what happened? I have no idea. Literally, I have no idea. But if I was to make an educated guess, what should? Probably it's going to truncate that, right? Something like that. Yes. So the answer to your question would be it depends. So depending on the programming language you use, and depending on the default behavior of your database, it either might truncate or it might give you an error. Hey, the maximum length of stuff you can store in this cell is 10 pins, 10 characters, and you try to store a name that's more than 10. So a good programmer or a good software database going to give you an error instead of truncating your data, right? But in all the software, the default behavior might be just truncating the data.
Do you have to define the default behavior for your database, or just secret?
You have to look up the default behavior of the database you are working with. And normally, as a best practice, as a programmer, if you are not sure about the default behavior, you make sure your logic handles all the cases perfectly. Okay, very good question. So in here, we saw in the previous slide, we throw in the varchar, we throw in the int, but what are the possible data type? The possible data type could be numeric. We have integer, float. If this is procycle, okay, someone who familiar with these type of name can tell me what is float for, or decimal for, and etc. You guys have seen this before? No. Yes, sir. Now I want to invite you.
Okay. If someone else. Okay. Cool.
No one else. That's why I invited you.
Okay. An int is an integer.
Okay.
Your float, I believe it's referred to. It's almost like a decimal, but has a limit on the number of decimal
Okay.
points that it goes out to, and then a decimal just holds as much as the value is.
Okay, so both float and decimal representing a number that you have a dot and then a bunch of other precision points after that. So basically, you don't have to store even numbers. Numeric. So all of those are possible type of data you can store. Strings. You can do chart. You can do var chart. I don't even remember the difference between chart versus var chart. Look it up. That's what we do. Date and time. So date, time, year, etc. There's different variation of how you want to specify your day and time. It could be just day by itself, date and time, or just time by itself, or you just want to keep the year like 2019, etc. And then Boolean. What is Boolean? Not yet. I'm not inviting you yet. Let's see. So hold on. We have more hands. Yes, sir. Yes, you. True or false? Okay. What is true and what is false? But what does it mean for true versus false? Very good. All right, true or false is basically a decision, a result of an expression, right? That basically, true or false is the answer for a question. So if your expression is A equal B, question mark, the answer would be either yes or no, right? True or false. Or if you want to do a comparison, this variable or this string is greater than the other string. That would be an expression. So true or false would be a result of a question. And the two possible value of a Boolean is true or false. The comparable value for true is 1, comparable value for false is 0. Right? So that's why we name it as bit. Anyone understand the meaning of bit? Again, until you almost have a hand. Let me look to your first bit. Yes. Single 1 and 0. Anyone know the difference between? Anyone ever heard of bits or bytes? How fast is your internet at home? Okay, this is a very good question.
Hopefully, it's on the scale of megabytes.
All right. So you guys, anyone not living in the dorm here, you guys live in an apartment and you guys have to pay for your own internet? Or does your landlord pay for it? Raise your hand if you pay for your own internet. That you order your own internet. Okay, let me go over there. How fast is your internet? 80 megabits. 80 megabits. Who are you using? Spectrum? Verizon?
Spectrum, that's what they say it is.
Okay. 80
Nice! Oh my god!
Anyone has a different number, ma'am, in the back? 100 what? Megabits per second. All right. So let me tell you, if I have a per second, right? If I have an image on my computer that has a size of, let's say, 100 MB, okay, how fast would that transfer? All right, so the point I'm trying to make in here is that I think all you guys should may have known or might not be aware of. There's a difference between bit and byte, right? How many bits is 1 byte? 8, right? For technical people or for non-technical people, this is what we love. 8 bits is 1 byte. And the way that all of the internet provider out there is advertising is kind of like dumb down or play dumb on the actual bit versus byte. They advertise it. This one is 100. The other one is 80. But 80 what? Right? 80 megabits is 10 megabytes. And that's slow. That's super slow. Right? Spectrum is like everything you now for your download speed should be 100 megabytes or more, or like 80 megabytes or more. 80 megabits is like 10 megabytes. Man, I cannot play game with that. Right? Yep. Okay. So anyways, it's a sidetrack into that understanding. Definition of bits. What are we? This one. All right. So in this example, we have content, and we just want to label the data type we want to store in this content. So normally we just have a table and these columns with the labels with the name of the column and content. But in here, we kind of specify a little bit more. The ID going to be int. The USC ID going to be int. The all the text fields going to be varchar, first name, last name, and email, right? With the date of birth, we want to store it in the right format with the date, data type, and in the yes or no question, are they enrolling in this class? It's going to be yes or no question, okay? So in SQL, there's no in SQL there is no Boolean type. The type is actually bit. Okay. So now we have gone over just quick recap in the last 5-10 minutes. We understand how the table would look like, one table. We understand the primary key in that table. We're also understanding that what the foreign key would do in that table when we have that table linking to another table, right? In that linking, we briefly phrase the wording of one table links to another table, or another way of saying it, the foreign keys create the relationship between the two tables, right? So we first heard about the relationship. So now let's talk a little bit more about the relationship between two tables or two entities, right? Table entities have the same meaning. The relationship basically keeping track of the logical connection between the entities. And there are 3 possible types. So let's talk about the first one. 1-to-1. So what does it mean by 1-to-1? We are referring to the count of the number of possible occurrence, the count of occurrence, the count of the entity, the count of an entity in that relationship. I thought I have the maybe the exam will come up later on. The second type is one-to-many. I'm going to go through it quick, and then we're going to jump back to one-to-one with the real example. And the third type is many-to-many. All right, so here it goes. For the one-to-one, the example in here would be if you have 2 tables, if you have 2 entities. First one is keeping track of countries information. The second one, keeping track of the current president's information. Then the relationship between the 2 sides will be 1-to-1 because the possible occurrences of the country versus president would be one country have how many presidents at most? 1. The current president serves how many countries at most? 1. That's why it is a 1-to-1. So basically, we're asking ourselves that possible question, the question of the possibility of the number of occurring in that relationship for each of the entities. So, for the example of country versus current president is 1-to-1. Okay. Let me ask you, husband and wife. What would that be? Is that a 1-to-1? Or is it not a 1-to-1? It's kind of a hint right there, right? Like, I don't even know about the technical thing, but when I common sense, it should be a 1-to-1. And then we plug it back into the technical thing here. A husband, by law, should have at most 1 wife, right? And a wife, by law, should have at most 1 husband, right? So that is another example of the 1-to-1 relationship. Moving on to the 1-to-many relationship. So the example we have in here would be if you have 2 tables, if you have 2 entities, one entity is a football team, the other one is player, right? The question would be, for a team, how many players can be in the team? Many, more than 1. For a player, how many teams can he play in? 1, right? So in our example in here, we established the 1-to-1, or basically we established the count, the occurrences of the entities in the relationship. So in this example, it's a 1-to-many. Okay? One team has many players. A player can play at most 1 team. Can someone give me a different example that you could think of? Oh, one too many? That's plenty. Mom, a mom on the right hand side can have multiple children. Okay? If we were to say it the other way, a child has what? One mom only. Right? So another way is kind of weird, but when you are testing the one too many, right? From the one too many side, it is true a one too many. Right? One team has many players. One mom has many children. But when you are testing the other side, it's kind of a hidden one-to-one. Does that make sense? A player play at most one team only. If you are testing the other side, a child belongs to one mom, at most one mom only, right? So that's kind of also a thing you guys need to keep in mind. Anyone has a different example? Yes, sir.
Each student belongs in multiple classes or has multiple classes.
Okay, very good. I'm gonna pick on you now.
Okay.
Very good. Lucky you volunteer. I didn't point out. All right. So football versus players, right? Mom versus children, and then you say
Student.
Student versus classes. A student. What did you say?
Multiple classes. Has multiple
Has multiple classes. A student has multiple classes. One too many. Right? Good. Go back to my example of team versus player. A team has multiple students. So it's kind of pretty much the same, right? When I pass the other way around, a player belongs to how many teams? One team. All right, so let's do this. Student has many classes. A class has how many students?
Many students.
Okay. Right. So that's a very good example for the many to many. All right. So that was an example. Actually, if you look ahead, I don't know, but we really just point out to this example. A class has many students, so that's one to many on this side, right? And then on the other side, class has many students. A student can take many classes. So all combination is going to be many to many, meaning that many students could be in multiple classes. Classes multiple students. So that's an example of the many to many. Any question on this? All right. If you don't have question, then I have question for you. Exercise. Person versus cell phone. What is it? We have only 3 possible answers. One to one to many to many.
One to many.
All right, 3 answers. Who says 1 to 1? 5, 6, 10 hands. All right. Who said 1 to many? The same number of hands, a little bit more. All right, put it down. Who said many to many? Very good, only me. All right, so it's not true. That's it's many to many, right? So we have 2 possible scenarios. Which one is correct? Is it 1 to 1 or is it 1 to many? Well, who said 1 to 1? Raise your hand again. Raise your hand to explain to me why you think it's 1 to 1. Yes, sir.
Person in general has one cell phone. They can't have more, but they usually have one.
Okay, good. For the people who said 1 to many, can you tell me your...
Some people have personal cell phones and cell phones.
Okay, so should I trust him? Should I trust you? Trust you? He said I should trust him. All right, so how should we conclude? Yes, sir.
Well, in a one-to-many relationship, that allows for users who only have one cell phone, but also lets users be associated with many cell phones.
Okay, so who's correct?
The one-to-many. Like the one-to-many can encompass both.
Okay. All right, so for this, the correct answer is it depends. All right, you guys are the developer. You guys, in my class, I keep saying you guys are the database analysts. You got to think. You got to know how to think. The same thing with us. When we are designing a database, okay, everything depends on our analysis, okay, case by case situation, on our assumption. If we assume, if we make a rule, if we make a policy in our implementation that a person should only have a cell phone, if that is the true fact that we believe in, then it is a one-to-one relationship. In other cases, if we're supporting a general public that, hey, a person might have not even a cell phone or business phone. I have 2 cell phones. So it's just one too many, right? So the answer would depend on the assumption of your scenario. So the answer is it depends. And both could have been correct. Right? So moving on, I think I have slide 20. What slide number is this? Messed up here. I want to make sure that I can finish on time. Quickly, person versus home phone. Person versus cell phone. That could be 2 possible answers. Person versus home phone. 1-to-1. Raise your hand if you think it's 1-to-1. Couple of hands. All right. If you think it's 1-to-many, just a couple of hands. All right. How about many-to-many? So what is this? Someone want to tell me? Yes, sir. You want to say something?
Well, like multiple people in the house can use the same phone.
So say first, which type of relationship you think it is?
I think this one's
You think it's many-to-many?
Yeah.
Okay. And now explain that.
okay. So like multiple people. I mean, you have more than one home phone in the house, and one home phone can be used by multiple people.
Okay. So that is his justification, right? And that is his assumption. And my answer would be, if that is his assumption, it is correct. It is correct. Your conclusion is correct based on your assumption. And this assumption was multiple people, okay, your dad, your mom, you, your sibling in the home could use a home phone. So a home phone has multiple people belongs to it. And also, in the home, there might be multiple home phones, right? Multiple phones in the home. The home phones, desk phones. And with that assumption, many-to-many. But if I was to go out there and do a survey, and based on my common sense understanding, I would say this is more on the 1-to-many. But in the explanation of, there's only one home phone per household, but that household or that home phone belongs to multiple people in that household. Does that make sense? Okay, so move on to the next thing. I have a longer concept out there, but let's hope we can go through these examples. Traveler versus country. What do you guys think? Raise your hand and don't just count. Raise your hand and tell me what you think it is. Who volunteer? Yes, ma'am. 1-to-many. Okay. One traveler can go to multiple countries. Very good. How about the other way around? Okay, so is that a 1-to-many? Yes, sir. Okay, why is that? All right, so it's a many-to-many, which makes more sense. We have to kind of test both ways. A traveler can go to multiple countries. A country can allow many tourists, right? This is a many-to-many. Very good. National flag versus country. This is very similar to our previous example in the other slide. What is this one? It's 1-to-1, right? For sure. Amazon customer, you guys, versus purchasers. Purchasers is the same thing as saying orders. The order you place. So what is this? All right, raise your hand and tell me what do you think. Yes, sir. Many-to-many?
Because customers can make many purchases and purchases can have many customers.
Okay. A customer can make many purchases. Very good. A purchase could what?
To have many.
Does that make sense to you? No? All right, so very good. We have to test that. So he would say this is a many-to-many. I would say it's a 1-to-many. As in, a customer can make multiple purchases. On our website, a customer can place multiple orders. Today I place an order, right? I buy something. Tomorrow I place an order. I buy another thing. So I can make multiple orders or purchases. But a purchase, an order, belongs to one customer only. So it's a 1-to-many. Does that make sense? The last example would be Amazon product versus purchases. Slightly different. What is this? Amazon products like iPhone, iPod, water bottle, candies, purchases are like orders, right? Order 1, 2, 3, 4, 5, placed on this day, that day, this time, that time. What is this one? Amazon product versus purchases. What should it be? Right, raise your hand. You think many to me. Why?
Purchase products in it, and then both folks different purchases.
All right, so it's many to many because a product can belong to multiple purchases. A product can be placed in multiple purchases. And a purchase can have multiple products in it, right? So an iPhone could be ordered multiple times in multiple products. I'm sorry, in multiple purchases, right? You buy an iPhone, I buy an iPhone. All of those are different purchases. In my purchase, I can buy multiple products. In my purchase, I can buy an iPhone, iPad, MacBook, right? So both ways are the many to many. So in this example, in the last example, it is a many to many. Okay. So all of the exercise we do, all the things that you guys actually have to do prior to you designing your database, prior to you implementing something with your code when you want to create a database to store some information. In simple term, in simple example, you can just throw a table together and bundle everything together. You don't have to separate out a table, and that's fine. But if you need to kind of section out the tables and create a relationship so that you can have the linking definition of relationship amongst the table, you gotta think about the type of relationship you want to create that makes sense, that is valid for your scenario. Yes, ma'am.
For the last one, I was confused because I thought you had that one specific product versus purchases. So that if one product has a specific product ID, wouldn't it be one to many? Because like a lot of people can buy that one thing, and that one thing can be bought by a lot of people.
Very good. So if you guys don't want to listen to my explanation for this, it's going to be confusing. That's fine. Just tune out, ignore this. The question to you is very good. So let us define what product means. I think what you were referring to is item ID, a unique item. What I'm referring to would be the general concept product.
Oh.
So when we think about product, an iPhone is a product.
Okay.
If I talk, hey, Amazon and Apple came out with 5 products last year, how would you understand it? Oh yeah, they have a new version of iPhone, new version of iPad, a new version of Apple Watch, a new version of MacBook, etc. Right? So that's what we're referring to. The product is just a generic name. It's not a specific item produced under that product. Right? So if you are using a specific item produced with a specific item ID, yes, that's going to be one to many. Okay. Now we know about the relationship type between two entities, right? We talk about entities in pair. We want to kind of put them all together. So this is one example of after you have figured out the relationship type between set of entities, but in your database you have multiple sets, you have multiple entities. You got to all bundle them up together and put them all on the same map. So this is one example of what we call an entity relationship diagram. You're going to see this a lot when you're reading things related to database. This one is literally just saying it is a diagram of the relationships among the entities. Simple as that. So if you look at these as a pair of the two boxes and the line between them, it's literally telling you that the coach versus team is that the coach can coach one team, but the team could have multiple coaches. Okay, so each box represents an entity. You don't have to understand all of these tiny little syntax or notation. You're going to learn more about this one in the bicycle workbench that I'm going to show you later today or in next class. In here, you can get a taste of the final mapping, the final diagram, that how it would look like when we put everything together, and there are relationships among them. Okay. Another thing which I don't know if I can do that. My next slide will be putting up a real world example. What time I have? Okay, cool. So let me do this one. David, pull up. I want to put it up on. And this is a project. If I don't know, I don't remember. This is the one that we worked on. All right, so I'm gonna show you guys. Let me see. I don't want this anymore. This. Hopefully it works. All right, so this is a industry real world example of what that diagram would look like when you have designed your database. So this is the backend information storage database design of one of the project that we worked on, where there was a home front game, right? I think it's a shooting game, and also the game developer wants to, or the producer of that game, distributor of that game, want to make a fun little side activity and ask us to create an application for them to allow the people who want to site to register, when they have earned some points in the game, they can socialize, etc. And we basically designed this whole thing back and forth on. And you guys don't have to understand any of this. My point is to show you guys how that diagram would look like in real world project. And this is one of the very simple projects that we did that have like 10 little boxes. And the lines among the boxes would be the relationship we have to establish among them. Okay, so that is just a quick note, sample on how the real world thing would look like. And with that, we now move on to the last part of our lecture, which is going to be a topic about normalization. So now, for normalization, how should I say this? This is the concept that I'm going to fly over just to give you guys a taste of what the step would look like. We're going to see one very simple example, and we're going to see one very complicated example. You guys don't have to memorize or know all of the details, okay? So the point here is that introducing you guys to the concept of normalizing your database without asking you guys to understand every little detail concept, because this is one of the hot topics. And today's lecture, 2 hours or an hour and a half, I am condensing 5 of my individual lectures into this one single lecture. So for sure, I might not be able to cover all the little details, and you guys will not be able to understand all the little details. So the point from now on would be highlighting to you what it means when we say normalization and the main step, normalizing a database. So when we talk about normalization, what do we mean? We mean that given a database design, the ERD that we saw in my industry, my real life example, it looks good, but is it really good? Do we know? We don't. So we have a step, we have a process of double checking to make sure that if we need to reorganize, restructure the database to improve it, to reduce the issues or another term for anomalies, we're going to do that. So the normalization is nothing other than reorganizing your database to reduce the issues. Okay, so what are the issues that could be? We have 3 possible type issues in here. The first one would be on the first table, looking at the data in there. Let me ask you, if we need to update the cost, the acquisition cost of the 2 press, what do? Right now, what is the cost for that? 3,500. If I need to change it to 5,000, what do I need to do? Literally, in that 6 rows of data. What is the Excel table?
You have to change 4 different entries.
Okay, I have to change line 1, 3, 5, and 6. I have to go to 4 lines to change that cost. So we kind of see what of the issue we have is that we are being repetitive, and we need to go to multiple places to update the data. So that's one of the issues we try to remove when we go through normalization. Second one is delete. In the second table, if the student ID 100, the first line, is not taking the skiing, so in that table we're trying to capture the sport club during the summer. So basically the student registering for any activity during the summer, right? And the fee associated with that. The second issue in here we have is looking at the second table, and if the student with the ID of 100 joined the sport club in the beginning, but then decided to drop out, we need to delete that row. What will happen? When you see something that might go wrong, where we need to get rid of the student 100 and the data associated with it. Yes, sir.
You have to delete the whole row and not just the ID.
Okay, I have to delete the whole row, which is fine, but when I delete the whole row, what is the implication of deleting that whole row?
You suddenly forgot about the data.
Exactly. By looking at the data, we have only one instance of this skiing that has a fee associated with that, right? And if we delete the student 100, we actually will delete the fee associated with skiing, meaning that we just need to get rid of the student enrollment information. But by deleting that enrollment, we also delete the associated data, which we don't want to delete, which is the fee associated with skiing. You see that? So that's one of the issues that through normalization we try to get rid of. The third one would be similar using the same table. If we need to add in the new sport, the new activity called tennis, and the fee is 100, good. How do we add that data in? We're going to be creating a new row and putting activity as tennis, putting the fee as the fee as 100. But what else are we missing? Okay, looks like that if we have the data structure on the table like this, then our student ID in this cell, the new row, is going to be empty because we don't have any meaningful value to put in. So that's going to be creating a hole in our table, which is actually the issue, right? So these are just a few examples of what the issues might look like when you have a database that may look good, but actually internally it's not looking good, right? So the normalization is a process we are going through to try to improve that. So for example, in this simple course table, can you tell me what are we trying to keep track of? Yes, sir.
The course number, the name of the course, the room that it's in, and the building that it's in.
Okay, so this is a very simple table. We're trying to keep track of the main course information together with where that course might be. But we can normalize this one a little bit further by splitting unrelated data or data that could be into separate entities. Okay, so we have normalized that the original table into the new version of our database, the new design of our database, by splitting that table into two tables, okay, and referencing one table from another by using a foreign key. So this is one of the very, very basic example of normalization. Basically, we're just splitting information so that each entity is kind of by itself without a bunch of other irrelevant associating data. The only associating data we have in here would be this linking to which room we have. But let's assume the rooms table in here is not only having this room building, but having like the alarm code, who's going to be the manager for that building, a bunch of other stuff in here. This table is going to be very long, this side. And if we keep that information in the original table, our original table is going to be very long. So we don't want that. That's why we kind of separate out. If there are two different entities that are meaningful by themselves, the course and the rooms, let's separate them out. So this sample example is what we try to do with that. And now I'm gonna show you the second example, which is the last example in our class, in our lecture today. And this one, believe it or not, is gonna be very, very boring. Okay? So you either stay awake or you can go to sleep. But the point is I want to show you a bigger, a more complicated scenario so that you are aware of if you have to face it, or at least if later on you have to do the normalization for something complicated, you can refer back to these slides and look more into details. So this is the example that we have. You guys are given the task of, hey, this is the data we have in our database. One single table with a bunch of information. And the information that we are trying to keep track of in this original table is project-related information, right? We have the evergreen project, that we have a few employees working in that. Have a green project where they have worked a certain hour, they have their rate, and this is the role that they are taking in the project. So overall, that is the information we're trying to keep track of in that. But it's kind of like everything putting together, and we don't think it is as clean as we can get it, so we're going to try to normalize it. Below here, in the below here, we call this one is the dependency diagram. In the presentation now, I have a lot of definitions for you guys. In short, this is a diagram that's showing you the columns in the table. We have 1, 2, 3, 4, 5, 6, 7 columns. We know that these 2 columns by itself, with the highlighted column, project number and employee number, all together is the primary key. And we represent the primary key by the top arrow. Okay, so that's actually on the top. All of this on top is one single arrow with the root coming out of 2 columns. And the tips pointing to the rest of the other columns. Okay? The second arrow would be from this column pointing to the project name. The third arrow would be coming out from this employee name, employee num, and pointing to these 3. The fourth arrow would be job class pointing to short hour. So I've just explained to you what the diagram means. This is basically the notation of diagramming the dependencies. So we have 4 dependencies or 4 arrows. In the presentation note, I explained to you what it means by a dependency or a longer name of this functional dependency. You can think of the dependencies is a similar version of the primary key. So with the primary key, if you know the key, you would know the rest of the record, right? Makes sense? If you know the ID of the student is 1, you know he's John Smith. That makes sense, right? The dependency is a smaller version of that slightly, pretty much the same, just slightly different. Is that if I know the project number, not only for the primary key, you can know the rest of the column, the rest of the table. But in this case, knowing the project number, you only know the project name. So project name depends on project name. Or project name determines project name. So that's the definition of the dependency. One thing determines another thing. A smaller scale would be if you know job class and basically their title is their engineers or accountant, you would know their rate. Right? So this is not a dependency. Or saying that the title, the job class determine their rate. So the understanding of each of these individual dependencies is very similar to primary key. The primary key covering the whole table, all of the columns, versus dependency would be just a subset of these columns. So that would be my explanation for the overall understanding of the dependency. And the reason we have to look at the dependencies is actually that is one of the key steps for us to understand how to normalize the table. The goal would be, in this table right now, we have so many arrows pointing to each other, pointing to various rows. And our goal ultimately would be, let's split them so that we have smaller tables. And in those smaller tables, we have only 1 arrow per table, if that makes sense. So that would be the overall goal. Okay, visually. 1 table with messy arrows because there's a bunch of dependencies altogether. One thing depends on another thing. Let's split them out so that we have a bunch of smaller tables. In each of the table, only 1 single arrow.
So what's the advantage of dealing with smaller tables?
They are more concrete. They are separated. You don't coupling the data, because when you're coupling the data, for example, let's look at this. Project number is 15. What is the project name? Evergreen, right? I am project manager. I don't like green color. I need to update it to ever red, etc. Then you go to everything in here to update that. The same thing is that if I want to replace the guy named programmer in here, but then it changes his title here, you're basically going to a bunch of other roles in the project that's unrelated to the set to the employee, just to change his title. So we don't want the title to kind of bundle all together too much, and that's the reason we want to separate them. Okay, 34. How much time we have?
16.
All right, I don't know if I need to fly through this one or not, but it took longer than expected. Okay, so real quick on this slide, you guys see how the table look like, one original table and a bunch of dependencies. In the next line, the way we would do this would be very simple. See the project name and project name. Let me just walk you through one simple example, project name, project name. I'm going to try to split this data. Okay, so project name and project name. We're going to try to split it by, you know what, put it into a different table, split it out. So we split out the project name into a new table. Okay, that's why I have the word shut in here. And since the project name, we know it's kind of determines the project name, we copy it here. We're still leaving it here. But since we're copying it here, for the understanding of data and the foreign key we learned earlier this class, we need to mark this one as a foreign key in the original table. So basically, this is the step where we have split the original table into one small table and the remaining data in the original table. Okay, so this is one step. Another step would be, if you guys look at this right-hand table only, what we're going to try to do next is that we know that employee number, kind of the ID of employee, has the associated, hey, his name, what he does, how much he get paid, right? So these 4 columns in this table on the right-hand side, it's kind of related to each other. The next step we would do would be, we're going to try to split this table out into tables by bringing this thing out into a table by itself. Okay, so on the project, we already did that. We split it out into a project-related table by itself. And the next step would be, hey, let's split the employee out into a table by itself. So how would that look like? It look like this. So the project number, the project table is still there from the second step. We leave it there, we don't touch it. What we have done is this middle table, in this table, or previously, in the previous slide, we split them out into 2 tables. This is the new table we created. We have the employee number, what their name is, what they do, and how much they get charged. Right? So we cut it out here. This is what remains in that table on the previous slide. This is what remains in the table on the previous slide. Then here, you kind of see that we try to move from one step to another by splitting out the entity into its own separate table and leave kind of the remaining as the relationship between these entities. So by looking at the project name and project name and employee number, and you know, for each project, we have a bunch of employees working in that project, right, by using the IDs. The last step we're going to do is that middle table. We still have something that relates to each other in this table. You know that when you know the title of the job, you know the rate for the job. Right? If they are engineer, all right, you're going to pay $100 everywhere. If they are accountant, you're going to pay like $50 everywhere. So this is another dependency that we want to try to kind of cut out as well. Very similar. Every single step we do, we see something dependent within a bigger table that we can cut out. We're going to try to do that. So the last step would be splitting that middle table into 2 smaller tables. So our employees still stay here. But then we just split the job class, so basically the title and the rate differently into a new table because we think that these 2 can be by themselves in a brand new table. And the diagram on the bottom left is the updated, basically just the same understanding of this table, but the updated list of arrows or dependencies we had at the last step. And if you guys remember, I mentioned that the goal we try to do with normalization is converting that one single table with multiple arrows into smaller tables, and each table has only 1 arrow. Correct? So if you guys don't understand fully the baby step that we have done, it's totally okay. This thing took me one full lecture. This at the last 5 or 10 minutes, so definitely we cannot go over the details. However, all the steps are in the presentation notes. Okay, that will help you, guide you through the understanding of figuring out the functional dependency. What does it mean for partial functional dependency? What does it mean for transitive dependency? So those are the two new definitions that you can use in presentation notes and can use that to Google and look up more material online. But the step I have outlined in the last 5 slides is actually the concrete step that you can look at later if you need to do some sort of normalization in your new database. Anyways, this slide right now is the result, the end result, after we have normalized our one single table into four small tables. All right. Now, the last step would be this. Lion, do you want them to do this in class or no? Okay. All right. So there's no more slides after this one. This is supposed to be an in-class exercise. Assuming that we have gone through the last 5 slides, me explaining to you guys how to do normalization. This is your time to do the normalization. Okay. So we can try to do this all together. The way I tackle this will be looking at the data and then figure out what are the dependencies. Again, definition of dependency. Just remind ourselves about the primary key, and dependency is just a smaller version of that, right? So let's figure out what is the primary key for this. Do you know? Well, looking at the list of columns, you kind of see that we keep track of 2 different things in here, right? Have the movie information toward the left-hand side, kind of, and more information related to the director on the right-hand side, right? You can kind of see the main concept. We're showing 2 different things in here. So with those 2 different things, each of those is going to have something identify itself as a key for itself, right? So we can say that for the movie ID, if you know the movie ID, you know all the information related to the movie. Same thing, if you know the director email, we can consider this one as the director ID. You know the rest of the information related to the director. So for this table all together, this column and this column combined, 2 columns, is going to be our primary key. Yes, sir.
But you have 2 directors who have the same email.
Exactly, that's what I just said. For this table all together, the primary key would be not only this column, but have to be these 2 columns combined. Right? With these 2 columns combined, the values will always be unique. Follow that?
Yes.
Okay, so we're good with that. So that would be one thing, right? We identify the primary key, which is our biggest dependency. 2 other dependencies that we can kind of figure out in here is that when we know something, we also know something else. So if you know I said earlier, if you know the movie ID, you kind of know these 3 columns, the movie associated information. If you know the director name, you kind of know this, right? So I'm not saying this one is the key. I'm saying this one is a dependency. Because knowing the name is James, you know for sure he's James, etc., and his date of birth. So by examining data, we have also identified 2 other dependencies. So in total, we have 3 dependencies. One is primary key. The second one is for the movie. The third one is for the director. So the step would be trying to split those out. What we would have as a final state would be 1 column for the movie itself. I'm sorry, 1 table for the movie itself, consisting of movie ID, title, movie cross, and year. The second table would be for the director themselves, director email, director name, date of birth. The third table would be the remaining table, where the columns remaining in that table would just be the movie ID and the director email, basically establishing the links between which movie has which director directed which movie. So that would be the final version of the normalized database starting from this. Okay? All right. I know that I promised you guys the last 15 minutes is going to be boring, right? And I think I succeeded with that. With that said, you want to do whatever you need to do or no? Okay. All right. So yes, sir. Yes, ma'am. Oh, I think a Nyan gonna. This is Google slide you share with them, right? Okay.
Are there
But
separate notes?
when you share with them that they don't see a presentation note. I think when you share the Google slide, they have access to the presentation note. But I think even with the embedded version, they can still get to the presentation note.
Okay. Yeah. That's the thing.
Yeah, they are able to. But anyways, thank you so much, guys, and I won't see you guys again in this class. But good luck at school.
Can we get a round of applause? Alright guys, there's no lab due Tuesday, hooray. Because today was more of theoretical thing. But there will be an assignment on Sunday after we cover a little bit. Now that we learned how, what is database, we're going to do how to make those diagrams on Wednesday.
So you said you teach like other ITP courses here?
I teach only for now the ITP303, basically a database focused version of what I just talked about. Instead of this one lecture, literally you had 5 lectures with me for this. Yeah.
Okay.
Are you computer science? Sounds like you are computer science.
I'm CSBA, so computer science.
Sorry for picking on you. I was just playing around.
No,
okay?
I'm used to being the guy who always volunteers.
It's very good. Very good. Because you ask more questions, you're gonna learn more. I know that. So
Yeah. I'm used to in a CS class, no one asks questions.
yeah, either they understand everything or they don't understand anything to even ask questions.
Yeah.
Just ask question means that you are understanding.
I was going to ask if you have a business card or...
You can ask Nayan for my email. I have my USC email.
Okay.
You want to write it down? I can give it to you.
I mean, I can always ask, because...
Okay. Yeah.
Are you thinking of teaching more here? I don't know if USC pays more than UCLA.
I don't teach at UCLA.
Oh!
I work in the industry.
Okay.
I have my degree from UCLA.
Okay.
I'm only teaching it part-time because I have all the business that making me more money. I only teaching here, and the other thing I would like to teach here more, but it gotta fit with my schedule.
Okay.
So the only thing that potentially might be would be the next couple of few semesters if it works out.
Oh, okay.
If the schedule fit, is me teaching another programming related class in the morning because my class is typically in the afternoon. But it's more about the scheduling because I could only come here 1 day a week, so that's kind of restricted.
Would you ever consider like recording like a lecture and like doing an online class?
He just asked what we talked about like a year ago.
What?
Because there are online versions of like a CS class or a programming class. Yeah.
You're just saying.
In CS department?
No, but like I heard the dean discussing it. Because the dean used to teach 109 for me, so I visit him every now and then.
Yeah,
Well,
so
I know that USC stance is for undergrads. They don't do online. That's been the general like.
Oops.
That's
policy.
been the trend, but they're
Yeah.
moving away from that. Like for graduate, they already have like 3
They have
graduate.
been,
Yeah.
But
all right, this
they've been
one.
pretty strict
Just
about.
real quick though, I think I just unblock it, and this thing is not good enough to pops up again on this. You know what I'm talking about? It was on the other screen. I should unblock it.
Oh, we didn't press stop.
We didn't press stop, so it's still recording.
That's fine.
Yeah, but I don't want to quit it.
You should-
But yeah, this doesn't show up.
I think
You don't have that. You don't have this.
But again, the other screen is not a different desktop. That's what I'm saying.
But it
It's
should.
not here.
Oh,
It's not.
I think you can press quit, and it's smart
No.
enough to know. If not, it's okay. We have the 2 p.m. class
Oh,
anyway. It
something
showed
to
up.
show. Can we move it here? No. No, not this. Yeah, I should have hit. Oh, we can get to the menu.
It should be smart enough to stop if it knows it could be
Wow.
distracted, it'll just stop it.
Meaning that you want me to quit? Show all.
And then just try what happens.
Well, I'm just gonna try.
Maybe if you quit, it would still have the file.
Report this 2 p.m. lecture.
Yeah.
Okay. Anyways, it was nice meeting you.
All right, sure.
Thank you very much.
Okay, no problem.
Bye. We have an assignment due Sunday. No
Yeah.
lab.
But no lab. Yeah. The lab is, it was supposed to be a design of database, but we didn't learn how to do that yet.
Lab.
So, not with like,
No, but-
not with Microsoft, so there will be an assignment.
Thank you.
Oh, crap. Put down already? Put up already? No, I don't want that. I don't need that. Student. Okay, it still look
Oh,
like
yeah, if you could, oh, cool.
no, right? I was quitting.
Yeah, if you could, no.
No, right? Here.